Here we're going to look at topic 2, section 3, or example 3, sorry, where we use linear equations to solve mixture problems. So a lab technician needs 25 liters of a solution that is 15% acid for a certain experiment, but she only has a solution that is 10% acid and a solution that is 30% acid. How many liters of the 10% and the 30% solutions should she mix to get what she needs? All right, so we need 15% acid. However, we only have 10% acid and 30% acid. So we're going to have to find some combination of 10% and 30% to get us down to 15%. Now, keep in mind that 15% is closer to 10 than it is 30. So you're probably going to need more, not probably, you will need more of the 10% acid solution. So when you get your final answer, you do want to check to make sure that in this specific case, you should have more of the 10% acid than you do the 30% acid. All right, so let's come up with some type of equation. Well, we know that we need 25 liters of 15% solution. And that is made up of, or has to be equal to, we don't know how much 10% acid solution and we don't know how much 30% acid solution. So let's say the 10% acid solution is X liters of 10% solution. All right, again, that's what we're trying to figure out. The liters is the unknown. And when we're mixing the solutions, we're going to put them together. So we're going to add them. So the 25 liters will be made up of X liters of 10% and something liters of 30% solution. Now, how would we determine what liters we would put here? We want them in terms of X. So this is going to have to be something with an X here. Right? Something with an X. Well, if we know we need 25 liters, and we know that we're having X liters of 10% solution, it would only make sense for it to be 25 minus X liters of 30% solution. All right, so again, our total would be 25. We're taking X liters of 10%, so whatever is left over from that would be 25 minus 10. That's probably the hardest part, is just setting up the equation and figuring out what numbers to plug in. So we need to rewrite this kind of in some numerical values so we can look at this and solve this algebraically. 25 liters, we could just say 25, right? And then the 15% would be represented by 0.15. Okay, we're going to write that as a decimal. And that's going to be equal to the X liters, so it's going to be X times our 10% solution, which will be 0.10, plus the 30% solution, so 0.30, times the number of liters. These two steps here are by far the hardest part of the problem, is first setting it up in kind of words and terms, really determining what your original equation is, and then actually forming the algebraic version of it. Make sure that you turn the percents into your decimals. So from here, we can now begin to solve. We want to simplify this and start moving some terms around. So the 25 times 0.15 or 0.15, that's going to be 3.75. So we'd have 3.75 here. 0.10x, multiply that, we can get rid of the parentheses, so we'll have 0.1x. And then here, we're going to add 0.3 times that 25 is going to give us 7.5. And then 0.3 times a negative x is going to be negative 0.3x. All right, notice that I got rid of those, the 0 here, I didn't have to show that. And the 0 here, I didn't have to show that any longer. So let's combine our like terms. We have 3.75, 0.1x minus 0.3x. So I'm going to combine these two, and that would be negative 0.2x plus 7.5. And now we can start undoing operations and moving things around. So we're going to subtract 7.5. 3.75 minus 7.5 is actually negative, sorry about that, negative 3.75. That equal to negative 0.2x, and then we would divide by negative 0.2. So those will cancel out. So x would be equal to, and when we work this out, we would get 18.75. All right, now we're not done because we didn't actually answer the question yet. We just solved the equation. What did the 18.75 and the x represent? Well, that was the amount, the liters of 10% solution. So 10% solution, we need 18.75 liters. And then for the 30% solution, well, the 30% solution was 25, let's write that down here, 25 minus x, so 25 minus 18.75, which is 6.25, so we get 6.25 liters. So 30% solution, we would need 6.25 liters. And that would be our answer. Now you can check this, you would plug the numbers back in and make sure it works. This is the easiest part to check, just make sure that adds up to 25. But remember in the beginning, I said that since 15% was closer to 10% than was 30, there's a good chance there's a guaranteed chance you're going to need more of the 10% solution. And that's pretty much what worked out. All right, we needed almost 3 times the amount of 10% solution that we did need 30%. Mixture problems are usually not the most ideal things that students like to do. I know when I was a student, I wasn't a huge fan of mixture problems, but the good thing about these is generally once you find the form, once you learn these first 2 steps, any mixture problems are set up very similar to this. So you just have to learn the kind of process, and then you can repeat that process when they're asking for different mixtures or different types of solutions.